Okay, so our next theorem states that A intersect B is equal to B intersect A. Kindly correct for me, I think in the introduction I had said A intersect B is equal to B union A. Kindly correct for me, so this will be left to you as an exercise. So I want to focus on our next theorem, which says that A complement, open bracket, A complement, close bracket, complement is equal to A. So A complement is equal to A. So I want us to prove this in two ways. So we're going to start with this one. So we're going to say A complement implies that, if you want, you can put an equal sign. If you want, you can put that, which means that sign says implies or means. So A complement means, which is the same as, you can put an equal sign if you want. If you notice in the previous proofs, I've been using the equal sign. It's one and the same thing. In some books, you're going to find that. In some books, you're going to find the equal sign. So I'm trying to combine things so that when you find it in other books, you're not going to be surprised. So A complement implies that, open bracket, X is such that X is not a member or does not belong to A complement, close bracket. So we are saying A complement, we are saying is X is such that X does not belong to A complement. Okay, so at this point, you forget about the complement inside, which is A complement. So the complement, a complement means something does not belong in that set. Okay, so we are looking at this complement. It's the one we are defining here. So this complement means an element does not belong in A complement. An element does not belong in A complement. So X is such that X does not belong in A complement or does not belong to A complement. So this means, or this is equal to, you can put that sign if you want. This is equal to X is a member of A. So if an element, if an element is not outside a set, that means that that element is inside the set. I hope I'm not confusing you. So that statement means, let me give an example of you as a person again. So if I say you do not belong outside this family, what does that mean? That means you belong in this family. Is it not so? So that is what that statement means. X does not belong outside that set, which means X belongs inside that set. So if you forget anything about this proof, remember that statement. Something does not belong outside means that thing belongs inside. Okay? That thing belongs inside. So if you want, you can prove it the other way around. We can say, okay, let X be a member of A. We are proving it sideways. We are in reverse form. So let me call this 2 and let me call this 1. So we are saying let X belong to A. Let X belong to A. So this will imply that X does not belong to A complement. So if X is a member of A, that means this X does not belong to A complement. It does not belong to the set outside A. So this symbol does not belong to, what do we call it? We call it a complement. Okay? So we are saying X, so this symbol is called what? A complement. So you can say this is equal to A complement, this complement, again, another complement. I know it's not clear. Let me write it properly here. So we are saying A complement is equal to A complement and another complement outside. I hope that makes sense. So from 1 and 2, we can conclude that A complement is equal to A. A complement is equal to A. Hence proved. So this theorem, so let me just write this, hence proved. So this theorem is preparing us for our next theorem, which is the most and most. Okay, the other ones I was saying they're important, but this one is the most and most important theorem in set theory. It is called the De Morgan's theorem. It's called the De Morgan's theorem. It's one of the most important theorem in set theorem. Okay.